Hello everyone, let's continue looking into the contents of this particular course. So in order to explain the contents, we will start with a basic C program which will do an integer addition and the integer multiplication and division. So these two forms of basic building blocks of a scientific calculator app that you might see on your Windows machine, and as a result of that we are starting with these two basic addition and multiplication and division. So these C programs, once it enters into the compiler and into the RISC-V compiler, the output of the compiler will look something like this. It is basically nothing but a set of RISC-V instructions that is doing some operations that will perform the integer addition, and this set of instructions will perform the integer multiplication and division. Now if you try to break up these instructions into various parts, that itself forms the contents of this particular course. Now let me try to show you what I just said. If you look into the instructions like move or load immediate li or ret, these instructions are categorized as a separate set and they are called as the pseudo instructions. There are reasons why we call them as pseudo instructions. Apart from these instructions, there are some more instructions that comes under this category. We'll talk about that when we reach there. So pseudo instructions forms one of the content of our course. Next, if you look into the other instructions which are being highlighted by the red braces, they are the instructions that operates on integer numbers. They operates exclusively on integer numbers, and as a result of that, these instructions are being categorized as a base integer instructions, and they are being, and the nomenclature to represent the base integer instructions is called as RV64I, where RV stands for RISC-V. 64 is nothing but the 64-bit integer, whether this is being operating on a 64-bit or 32-bit. Based on that, it is called as RV32 or RV64. So if the data which it is functioning or which it is operating on is a 32-bit data, it is called as the RV32I, and if it is being done on a 64-bit data, it is called as RV64I. So in this case we are going to look into the RV64 integer instructions. So this set of instructions are the basic necessity for any hardware or any CPU core. Any CPU core that is going to be implemented should contain at least the base integer instructions being implemented. Okay, so that was about the base integer instructions, and this is the one of the content of the course that we are going to cover. Apart from the base integer instructions, if you look over here, there are two additional instructions that does the multiplication and the division function, and these two instructions, these kind of instructions are categorized as a separate set of instructions, and they are called as multiply extension. And the nomenclature to represent these kind of instructions are RV64M. So apart from the existing RV64I, if a hardware implements the multiplication functions as well or the multiplication specifications as well, the entire hardware is supposed to be called as RV64IM CPU core, because that particular CPU core does implements the base integer instructions and the multiplication instructions as well. So these are apart from the MULW and the division word, there are some more instructions in the multiply extensions. We are going to look into them as under the section of multiply extension. Okay, next, if you look into the floating point addition and floating point multiplication and division C program, this is how it will look like, and the output of the compiler of these C programs will be looking something like this. Now there are some new instructions which are present over here. Specifically, if you see the instructions which are appended by a keyword called as F. If you look over here, there's a keyword called as F. F stands for floating point, and all these instructions which are dealing with the floating point numbers, they are being called as single and double precision floating point extension. And there are some set of instructions like FSD, FLW that are categorized as this set of instructions, and the nomenclature for these instructions are RV64F and RV64D. So apart from the base integer instruction set, it can also implement it can implement the multiply extension, and it can implement the RV64, and it can also implement the single and double precision floating point extension as well. So a CPU core that implements all of them, it will be called as RV64 IMFT. So that also forms as the part of the course content. We are going to look into the various floating point instructions in this particular course, which are being referred to as RV64F and RV64D. F stands for single precision floating point extension, and D stands for double precision floating point extension. Okay, so apart from this one, if you look into the instruction set itself, you look into all the instructions over here, there are some keywords present over here and something like this. So these are nothing but the interface or the system calls which are available for the programmers, for the application application programmers, where the application programmers can actually access the registers of your RISC file directly using this interface. So this interface are being called as the application binary interface, ABI, and this is a very important system call function that is present over here. Every value over here, if you see, the return address is being associated with some register. S0, A1, A0 are being associated with some other registers and so on, and these registers are a part of your RISC file specification. So we are going to look into the ABI or the application binary interface, and also what does this ABI name corresponds to, which register does this ABI name corresponds to. We're going to look into that as well. Okay, that forms a very important that forms a very important part of your RISC file implementation. And then once we are done with that, we are also going to look into something called as, if you look into all these, the ones which are highlighted, there are some data transfer happening. The data is being transferred from the registers to the memory, or this is SP is the stack pointer. So there is some transfer of data happening between the memory and the stack pointer and the registers. So this kind of concept is basically called as the memory allocation and the stack pointer. So we are also going to look into how does the memory is getting allocated for all the instructions, and what is the concept of the stack pointer, and how does the stack pointer moves up and down based on the instructions that you provide. Okay, so that is another important point that we are going to look into. So apart from all this, we are also going to look into the representation or the 64-bit representation of a signed and unsigned integer, because without the understanding of the integer representation, nothing could be understood very well. So we are going to start with the signed and unsigned representation of integers. Next, we are going to look into the ABI and the memory allocation stack pointer, and once we are done with these two, the upper parts can be easily done, because these are nothing but the instruction formats and the way they are getting executed and the functions that they do. Okay, so the first part that we are going to cover over here is we are going to look into the signed and the unsigned integer representations. So let's stop at this point and let's start from the 64-bit integer representation from the next video. Thank you.